How powerful must an early warning aircraft be to turn the entire sky into a transparent hunting ground for the enemy? In recent days, high-definition photos and dense flight trajectories circulating within aviation circles have provided a stunning answer. The colossal aircraft designated 7822, alongside its sibling 7821, is streaking across the skies above a test flight base in northwest China at an unprecedented pace of parallel test flights. These are the two prototypes of the KJ-3000 early warning aircraft. This signifies that this aerial command center, which countless military enthusiasts and strategic analysts have pinned their hopes on, has passed its initial technical exploration phase and entered the final sprint to accelerate the verification of system stability and reliability. Recalling the past, while our KJ-2000 once joined the ranks of the world's top early warning aircraft with its large, phased-array radar, its core platform relied on the imported Ilyushin Il-76. Production numbers remained limited, and its range and endurance could not fully meet strategic demands. Behind that wall of airborne radar, there lingered a hint of helplessness stemming from dependence on others. Today, however, the KJ-3000 represents a comprehensive, systematic leap toward full technological self-reliance, from radar chips to flight platforms, from propulsion systems to software architecture. The most pivotal advancement lies in its intelligent, abandoning traditional fixed-array or mechanical, scanning designs. The KJ-3000 employs a technologically superior large-scale rotating active, phased-array radar. More crucially, its core our modules extensively utilize second- and third-generation semiconductor materials, gallium nitride. This transformation is far more than a simple parameter upgrade. It delivers a comprehensive qualitative leap in power consumption, efficiency, output, and thermal resistance. Public data and authoritative analyses generally indicate that its detection range for conventional large aerial targets can be reliably maintained at around 1,000 kilometers, forming an early warning perimeter capable of covering vast strategic sectors. Even against stealth targets with extremely low radar cross-sections, its effective tracking range reaches approximately 400 kilometers. This figure holds profound significance. It means that for most potential adversaries' stealth fighters, their approximate location and movements can be firmly locked onto long before any offensive action is initiated, significantly diminishing the effectiveness of their stealth capabilities. This represents not merely seeing farther, but seeing deeper and more accurately. The platform's novel choice forms the robust backbone underpinning its formidable capabilities. The KJ-3000 is built upon the entirely domestically produced Y-20B heavy transport aircraft, fundamentally resolving critical supply chain vulnerabilities and production capacity constraints. Four powerful WS-20 high bypass ratio turbofan engines not only deliver a maximum takeoff weight exceeding 220 tons and extended range, but also provide unprecedented electrical power capacity. This ample supply sustains the radar's staggering power demands and the vast array of onboard data processing equipment. The Y-20B's spacious fuselage has revolutionized the command cabin. More spacious and comfortable operator stations enable continuous three-shift duty patterns, allowing the AWACS aircraft to sustain aerial surveillance for over 10 hours or longer. This transforms the persistent presence of an airborne command post from a theoretical concept into operational reality. Analyses by media outlets like NetEase hit the nail on the head. This marks China's mastery of the entire life cycle, from design and R&D to mass production, of large early warning aircraft. Moving forward, we can deploy these force multipliers at scale according to strategic needs, much like producing advanced fighter jets. The simultaneous test flights of two prototypes across different disciplines exemplify this mature industrial capability. As observed by media outlets like Sahu, one aircraft focuses on challenging complex weather conditions and extreme flight envelopes to verify the platform's stability and adaptability, while the other immerses itself in simulated high-intensity electromagnetic interference environments to hone the radar's precision in real-world electromagnetic warfare scenarios. This parallel approach drastically compresses what would otherwise be a lengthy, sequential testing cycle, representing an exceptionally efficient and confident engineering management strategy. It indicates that core technological challenges in major subsystems have been overcome, shifting the focus to refining the entire system's robustness, human-machine integration fluidity, and reliability under extreme conditions. High-definition photographs reveal the aircraft's streamlined paint scheme, sharply defined radar dome, and distinctive WS-20 turbofan engines, all conveying a mature, near-production readiness. The high frequency of test flights silently signals smooth progress. When viewed within modern warfare systems, the KJ-3000's value multiplies exponentially. Far from being an isolated radar station, it serves as the central hub of a future integrated airspace combat system capable of both offense and defense. Through high-speed, anti-jamming data links, it can instantly synchronize the integrated panoramic air situation awareness to forward-deployed J-20 stealth fighters, J-16 multi-role fighters, H-6 and strategic bombers, and even surface vessels and ground-based air defense, missile defense units. It grants every fighter aircraft a bird's-eye view, enabling stealth fighters to conduct beyond visual range precision strikes even with their radars silent, and allowing air defense systems to execute optimized, coordinated interceptions. This fundamentally changes the rules of engagement, elevating the conflict from platform-to-platform confrontation to system-to-system confrontation, instantly converting information superiority into decision-making and firepower advantages. Adversaries now confront not merely an airborne early warning aircraft, but an intelligent, seamless, and real-time interconnected sky network. Thus, its strategic significance far exceeds that of a mere equipment upgrade. Across the vast Western Pacific theater, distance once offered the best cover, and stealth was the ultimate penetration weapon. Yet the KJ-3000, with its ultra-long-range detection and extended endurance patrol capabilities, will significantly mitigate the information degradation caused by distance, continuously eroding the threat posed by stealth technology. Any large-scale aerial maneuver will struggle to remain entirely concealed under its surveillance, fundamentally reshaping regional air power dynamics and compelling adversaries to revise their conventional operational assumptions. It serves as an unwavering aerial sentinel and a commanding strategist from the clouds. Looking ahead, the mass deployment of the KJ-3000 represents only a crucial step in China's construction of a comprehensive early warning and surveillance system. As many seasoned analysts advocate, the next imperative is to simultaneously accelerate the development of a space-based early warning system centered on high-orbit early warning satellites and low-orbit reconnaissance constellations. Only through the complementary integration of the KJ-3000 and satellite networks can we ultimately establish a seamless, all-encompassing early warning and surveillance system covering the entire globe, all time domains, and all airspace. The airborne early warning aircraft will handle high-precision, command-intensive operations in critical zones, while satellites provide wide-area surveillance and initial guidance. The fusion of their data and mutual backup capabilities will render any strategic or tactical surprise attack exceedingly difficult. This marks a decisive step forward in the People's Air Force's strategic transformation, from territorial air defense to an integrated airspace capability with both offensive and defensive capabilities. It also provides China with a more reliable, multi-dimensional aerial barrier to safeguard national sovereignty, security, and developmental interests. With accelerated test flights and imminent deployment, an era of transparent skies under our independent control is rapidly approaching.